Welcome back to Sleepless Mysteries. On July 1st, 2025, astronomers spotted something gliding silently into our solar system, a green-tinged traveler born of another star cutting across the black gulf of space. They named it 3 Atlas, the third interstellar visitor ever recorded. Like Oumuamua before it, like Borisov before that, it is a fragment of another world, a messenger from elsewhere. But unlike the others, Atlas may pass closer to the worlds we know, and some now wonder, could its presence change Mars forever? Mars is already a planet heavy with mystery. Ancient riverbeds snake across its deserts. Minerals in its rocks hint at life that may once have thrived. Just months ago, NASA's Perseverance rover revealed patterns in stone that resemble microbial traces, possible biosignatures, the strongest yet discovered. Mars may not be entirely dead, and if life once existed there, it may still linger underground, waiting. But what happens when a visitor from beyond the stars brushes past this fragile balance? 3I Atlas is no ordinary comet. Its chemistry is alien, its gases strange, its brightness unpredictable. It carries cyanides, metals, organic compounds, building blocks of life mixed with poisons. As it sheds its tail across the void, dust and particles scatter. If even fragments were to touch Mars, they could seed the planet with molecules never before seen in our system. Some call this contamination. Others call it panspermia, the spreading of life between worlds. Ancient myths once told of fire in the sky bringing change to the earth. To the Babylonians, comets were omens of fate. To the Chinese, they were messengers of dynastic upheaval. And in some Andean myths, stars fell and gave birth to new beginnings. Was this only imagination, or did our ancestors sense the truth that cosmic visitors carry forces powerful enough to alter worlds? Imagine it now. The barren deserts of Mars, still and silent. Above them, Atlas passes, its tail shimmering, dust drifting across the thin atmosphere. Some grains fall to the surface, melting into ice, seeping into rock. In those tiny reactions may lie the future, life rekindled or landscapes reshaped, a planet rewritten by a visitor from beyond. Science reminds us that nothing in space is truly isolated. Earth itself may have been seeded long ago by comets, its oceans filled by their ice, its chemistry sparked by their dust. If Atlas is part of this same cosmic cycle, then what we see today is not just an anomaly, it is continuity. Mars may yet be written into that story, its fate changed by a fragment from the stars. You don't need to see the comet's green glow to follow this. Just let these words carry you. Close your eyes if you wish. Picture Mars turning red under sunlight, while above an interstellar traveler sweeps past. Picture the dust drifting down, unseen, unstoppable. Picture a world being changed in silence, one grain at a time. Before we begin, if you haven't already, subscribe to Sleepless Mysteries so these quiet journeys into the unknown will always find you. Tap the like button if stories like this bring you wonder. And if you're still awake, share in the comments where in the world you're listening from and what time it is right now. Now, let the present fade. Tonight, the question is not only what Atlas is, but what it could leave behind. Could an alien comet change Mars forever? This is 3I Atlas. Could it change Mars forever? Unsolved mysteries for sleep. And it begins now. The arrival of 3I Atlas. When astronomers first detected 3I Atlas, they were not prepared for what they were about to see. Floating through the darkness beyond Neptune, it appeared faint, like a mere speck of light in the void. Yet, its motion revealed a secret that would spark fascination and debate across the scientific world. This object was not from our solar system. It had wandered here from the deep between stars, carrying with it mysteries that may never fully be unraveled. 3I meant it was only the third recognized interstellar visitor after Oumuamua and Borisov. Atlas was the survey telescope in Hawaii that caught sight of it, forever attaching its name to the object. But beyond those designations, what made 3 Atlas so strange was how familiar yet unfamiliar it seemed. It shared characteristics with both comets and asteroids, yet it fit neatly into neither category. Astronomers noted its brightness shifts, as though its surface were uneven, reflecting light in patterns that defied easy explanation. Sometimes it dimmed, sometimes it flared, almost like a heartbeat against the backdrop of stars. Unlike typical comets, its tail was faint, barely noticeable, and its chemistry, what little could be measured, was unusual, showing a higher proportion of carbon dioxide and organic compounds than expected. That chemical signature alone was enough to ignite speculation, for carbon-rich molecules have long been associated with the potential beginnings of life. But what drew even greater attention was its path. Calculations revealed it was on a hyperbolic trajectory, moving too quickly to be bound by the sun's gravity. It would not stay here long. Instead, it would slingshot through the solar system and eventually return to interstellar space. That fleeting presence made it all the more precious because opportunities to study it were limited to months, not decades. Unlike Pluto, unlike comets that circle back again and again, 3I Atlas was a once-in-a-lifetime visitor. As it moved closer toward the inner solar system, astronomers began to wonder how its journey might intersect with Mars. Predictions showed that it would not strike the planet directly, but the geometry of space travel is rarely simple. Fragments, dust, or gas released from its passage could easily drift into Mars's thin atmosphere. The idea that Mars, already the focus of human hopes for colonization and exploration, might soon be brushed by material from an entirely different star system raised profound questions. Would that material contaminate the Martian surface? Would it enrich it with ingredients from beyond? Or would it pass unnoticed, as silent and fleeting as the countless meteors that burn across our own skies? The fascination surrounding 3I Atlas grew in part because of how much it resembled a messenger. Unlike Borisov, which behaved much like a typical comet, and unlike Oumuamua, which confounded expectations with its cigar-like shape and strange acceleration, 3I Atlas was somewhere between. It seemed ordinary enough to be dismissed, yet curious enough to demand attention. That tension between the normal and the extraordinary made it the perfect mystery. Scientists struggled to observe it with limited tools. Ground-based telescopes caught glimpses of its shifting light curve, but the true detail of its surface remained out of reach. Space agencies discussed the feasibility of a rapid response mission, a probe that could intercept it before it left, but technology and timing conspired against them. By the time funding and planning could be arranged, 3I Atlas would already be gone. This sense of loss, of a door closing before anyone could step through, gave the object a kind of mythic weight, and in that myth, people began to project meaning. Ancient cultures often spoke of sky visitors, fiery messengers, wandering stars, celestial omens that appeared suddenly and then vanished forever. The Babylonians recorded comets as portents of upheaval. The Mayans associated celestial movements with cycles of death and rebirth, and even in medieval Europe, strange lights in the sky were linked to prophecy. For many, 3I Atlas fit into that long tradition. It was not just an astronomical object, it was a symbol, a reminder of how fragile our place in the cosmos truly is and how little we understand about what drifts between stars. At the same time, more pragmatic voices raised important concerns. If 3I Atlas did indeed pass close enough to Mars to deposit material, what would it mean for future exploration? NASA has invested billions into rovers, landers, and the Perseverance mission, searching carefully for any trace of ancient life while avoiding contamination. The presence of foreign organic material, literally alien from beyond the solar system, could complicate those findings. It could be mistaken for indigenous Martian chemistry. It could seed bacteria-like life if the right conditions were present, or it could vanish without a trace, leaving only speculation in its wake. The balance between danger and opportunity hung in the air, unresolved. The mystery only deepened when some researchers suggested that 3I Atlas might not be entirely natural. Building on arguments first raised around Oumuamua, they pointed to the object's inconsistent brightness and faint tail as potential signs of something artificial. A probe, perhaps, or a derelict craft drifting across interstellar space. While the majority of scientists dismissed these ideas as sensational, they spread quickly in popular culture. Social media buzzed with theories of alien messengers steering toward Mars, of ancient warnings fulfilled, of humanity standing on the edge of a revelation it was not yet ready to accept. Yet even without resorting to the extraordinary, the ordinary was extraordinary enough. 3I Atlas embodied the unknown. It was a piece of another star system, a relic of distant creation, wandering through our neighborhood for only a moment. Its chemistry hinted at secrets of formation, its path hinted at unseen forces, and its presence reminded us of how vast the galaxy truly is. For a world like Mars, Already on the threshold of transformation by human hands, its encounter with such an object seemed almost poetic. The arrival of 3 Atlas was not just an astronomical event, it was a cosmic story, unfolding before our eyes, inviting us to wonder whether the destinies of planets can be shifted not only by human exploration, but by visitors from beyond. And as it faded into the night sky, growing dimmer with each passing week, the question remained, had it come to simply pass us by, or had it left behind something we have yet to discover? Its unusual trajectory. From the moment 3I Atlas was spotted, astronomers noticed something odd about the path it traced across the sky. Most objects in our solar system follow well-behaved orbits dictated by the pull of the sun and the planets. They circle, loop, or fall into stable resonances. Even comets that dive in from the Oort cloud eventually arc back out on predictable ellipses. But 3I Atlas refused to follow those rules. Its orbit was hyperbolic, meaning it was not bound to the sun at all. It had come from interstellar space and would leave again, traveling on forever unless some extraordinary event altered its course. This realization placed it in rare company. Only 2 other interstellar visitors had been confirmed before it: Oumuamua in 2017 and Borisov in 2019. Yet even compared to those, 3 Atlas behaved differently. The calculations showed it had entered the solar system with a speed too great for capture. Its velocity relative to the sun was extraordinary, exceeding what any comet formed within our system could achieve. That meant it had been wandering the void for untold millions, perhaps billions of years before fate happened to steer it across our neighborhood. The question that followed was obvious. Why here? Why now? And why in this strange path that seemed to thread close to Mars? Part of the peculiarity came from its angle of entry. Unlike Borisov, which swept in on a steep trajectory, or Oumuamua, which approached from a relatively high inclination, 3I Atlas entered at an angle that carried it across the ecliptic, the plane where the planets orbit, in a way that almost seemed deliberate. Astronomers, of course, dismissed any idea of intention, but they could not ignore how unusual the geometry was. Its line of travel intersected not only the orbits of Earth and Mars, but also aligned with regions of space where gravitational influences are particularly complex. Gravitational tugs are what make orbital mechanics so fascinating. A passing object can be nudged this way or that, sometimes flung outward, sometimes slowed, sometimes even captured. For 3 Atlas, predictions showed it would come closest to Mars within a range narrow enough that dust or fragments could cross the Martian path. While the main body was too swift to be trapped by Mars's gravity, the potential for interaction lingered in every calculation. Scientists ran simulations, some showing fragments burned up in Mars's thin air, others suggesting faint streaks of interstellar material dusting the surface. A few speculative runs even suggested a microscopic chance of a fragment landing intact, embedding alien molecules into the Martian soil. But the trajectory also revealed mysteries of its past. The speed at which it entered the solar system implied it had been flung outward by some distant star's gravitational dance long ago. Perhaps it once orbited a sun not unlike ours, in a system that no longer exists. Perhaps it was a shard of a shattered planetesimal, cast out during the chaos of stellar birth. The mathematics of its movement contained hints of a cosmic history far beyond human comprehension. Every arc, every angle, every acceleration carried the memory of forces acting light years away. And then came the strange accelerations. Observers noted subtle deviations in its path, small shifts that could not be accounted for by gravity alone. For comets, these nudges often result from jets of gas erupting as ice sublimates, pushing the nucleus like tiny thrusters. But 3I Atlas displayed these changes even when its coma, the fuzzy cloud of vapor around it, was faint, almost non-existent. Was it outgassing in ways we could not see, or was something else at work? The debate split the community. Some argued it was simply a comet behaving oddly. Others whispered about artificial propulsion, a relic of technology sailing invisibly through the dark. To the wider public, the trajectory fueled endless speculation. The fact that it would cross near Mars only heightened the drama. Mars has always been humanity's mirror in the sky, a planet of myths, gods, and dreams of future colonies. For centuries, it was thought to host canals, cities, even life itself. Now, here came an object from another star, brushing close to that red world. It was as though the cosmos were staging an encounter we had no choice but to witness. Journalists picked up on the coincidence. Headlines wondered aloud if 3I Atlas might be carrying seeds of life ready to fall on Martian deserts. Science communicators pointed out that panspermia, the idea of life spreading between planets via comets, could gain its strongest test yet. If Mars were touched by interstellar dust, then the divide between native Martian and foreign would blur. Suddenly, finding organic traces there would not only tell us about Mars, but about the galaxy itself. Meanwhile, researchers ran orbital integrations forward and backward in time. Projecting its course into the past, they traced its path into interstellar space, but no clear parent star emerged. It had wandered too long, its memory blurred by countless gravitational nudges across the millennia. In the future, the calculations showed it leaving us behind forever, escaping at high speed into the dark. Unless another planet deflected it, which seemed vanishingly unlikely, its course was set, a ghost from elsewhere destined to remain elsewhere. And yet, for the brief window of its visit, its unusual trajectory offered something profound. It reminded us of the fragility of cosmic order. We like to think of the solar system as stable, eternal, a clockwork of planets and moons turning forever. But visitors like 3I Atlas prove otherwise. The boundaries of our system are porous. The heavens are not sealed. Objects come and go, carrying whispers of alien chemistry, alien history, perhaps even alien intention. Ancient peoples once looked to the skies and feared when wandering stars crossed familiar constellations. They saw omens of plague, war, or transformation. Though we now wrap these events in the language of physics and astronomy, a similar unease lingers. What if a trajectory like this one had been just a little different? What if, instead of glancing past Mars, it had aimed at Earth? The thin line between ordinary and catastrophic becomes clear in the mathematics of hyperbolic motion. Even now, astronomers continue to refine the data, measuring every flicker, every shift in its path. Each refinement brings new questions. Did it pass close to Jupiter on its way in, stealing a little momentum? Did it brush unseen dust clouds that altered its spin? Did its faint jets of sublimated carbon dioxide act like unseen thrusters, rewriting its path in real time? The answers are uncertain, the mystery ongoing. For those watching from Earth, the beauty of its trajectory lay not only in the numbers, but in the symbolism. Here was a wanderer free from the bonds of any star, slipping past Mars in a gesture that felt almost like a cosmic signpost. Whether we read that sign as warning, promise, or simple coincidence depends on perspective, but no one can deny its power. 3I Atlas, with its unusual path, reminded us that the universe is not a static place. It is alive with motion, filled with travelers whose journeys intersect ours only briefly before vanishing forever. And in that brief intersection, the question remains, was this path random, or was it part of a pattern too vast for us to yet see? The Mars connection. From the earliest predictions of 3 Atlas's path, scientists noticed something that set their imaginations ablaze. It would sweep close to Mars. Not close enough for a collision, but close enough for its dust, gases, and fragments to brush the red planet's orbit. This chance crossing was not just a celestial curiosity. It carried with it profound implications for what Mars might become and for what humanity might one day discover there. Mars has always been a stage where cosmic questions are asked. Was there once life? Could there be life now, hidden underground or encased in briny pockets of ice? And if there is none today, could humans one day transform its deserts into something living? Against this backdrop, the arrival of an interstellar visitor like 3 Atlas felt almost fated. If Earth was too far from its passage to be touched, perhaps Mars was the real recipient of its message. The connection begins with Mars's fragile atmosphere. Unlike Earth's thick blanket of nitrogen and oxygen, Mars's air is thin, tenuous, and unable to block much from space. Micrometeorites constantly rain down, and solar radiation sweeps through with little resistance. This means that dust or fragments shed by 3I Atlas would not be incinerated in the way they would on Earth. Instead, they could reach the surface relatively intact. Imagine grains of carbon-rich material from another star system settling on Martian sands, alien chemistry mingling with red dust that has lain barren for billions of years. Even if those grains are only molecules, their arrival would alter the planet's story in ways we are only beginning to grasp. Astrobiologists speculate endlessly about panspermia, the idea that life can travel across planets carried by comets and asteroids. If 3 Atlas carried organic compounds, as its faint spectral readings suggest, then Mars may soon bear a deposit of interstellar material that has never before touched our solar system. If such compounds seep into the soil or mix with traces of subsurface water, could they spark reactions leading to life? Or could they at least preserve evidence that life's ingredients are universal, scattered generously across the cosmos? This is why the Mars connection matters so much. The red planet may not only reveal whether life ever evolved there on its own, it could now show what happens when alien ingredients are added into the mix. The timing is uncanny. Right now, NASA's Perseverance rover is roaming Jezero crater, collecting samples of rock and dust that will one day be returned to Earth. If 3 Atlas dust truly does intersect with Mars' surface, there is a chance, however slim, that one of those samples could carry traces of it. Imagine the discovery: interstellar molecules embedded in Martian rocks, hand-delivered by cosmic chance into a container designed for human study. It would mean that humanity's first sample return from another planet also contained a gift from another star. This possibility has raised both excitement and concern. Planetary protection protocols are designed to prevent contamination, Earth contaminating Mars and Mars contaminating Earth. But what about contamination from outside the solar system? There is no protocol for that. If 3I Atlas introduces foreign chemistry to Mars, our interpretation of Martian life detection could become complicated. If scientists one day detect unfamiliar organics in Martian soil, will they belong to ancient Martian microbes, or will they be the fingerprints of an interstellar visitor that arrived just decades earlier? The Mars connection blurs the lines between native and alien in ways that shake the foundations of exploration. For colonization dreams, the implications run even deeper. Elon Musk and SpaceX speak of building settlements on Mars within decades. International agencies plan human missions that could turn Mars into humanity's second home. If 3I Atlas has indeed seeded the planet with complex molecules, colonists might encounter an environment that is subtly different than expected. Perhaps new compounds could enrich the soil, changing how crops might grow in Martian greenhouses. Perhaps they could pose unseen hazards, interacting with human biology in unpredictable ways. Colonists would not just be building a home on Mars. They would be entering into a relationship with a planet that has been touched by another star system. But speculation does not stop with science. The cultural and mythological significance of this event is equally compelling. Ancient peoples often told stories of fiery messengers crossing the sky, omens of change or signs from the gods. The Babylonians associated Red Mars with war, the Romans with divine struggle, and countless civilizations viewed comets as heralds of transformation. To many observers, the arrival of 3 Atlas near Mars felt like the fulfillment of such a cosmic drama. A red planet long tied to myths of conflict and destiny, now intersected by a visitor from the void. Even skeptics admitted the symbolism was striking. As data poured in, artists and writers began to imagine the possibilities. Some painted visions of glowing streaks of dust raining across Mars's skies, lighting the night with foreign fire. Others imagined astronauts of the future picking up pebbles that originated not from their world or ours, but from a star beyond imagination. The Mars connection became not just a scientific curiosity, but a narrative, a story about how cosmic wanderers can touch the fates of planets. Meanwhile, astronomers kept running simulations. They tracked the likely paths of dust streams, measuring how solar wind would scatter them, how Mars' weak magnetic field would shape their fall. Some models showed faint interstellar snow drifting into the upper atmosphere, burning into wisps of gas that might alter its chemistry for months. Others suggested particles could embed into polar ice caps, preserved for millennia as records of an alien encounter. If future explorers drill into those caps, they may find layers that whisper of a time when another star reached across the void to leave a trace. There is also the question of what Mars might give back. If 3 Atlas sheds fragments onto the planet, then its trajectory may also carry Martian dust outward, hitching a ride into interstellar space. In that sense, the connection is two-way. Mars could send its own fingerprints, iron, silicates, maybe even ancient microbial fossils, into the deep black, where one day another civilization could discover them. The red planet would then become not only a receiver of alien gifts, but a contributor to the galactic dialogue. The deeper mystery is whether this has happened before. Mars bears scars of countless impacts from comets and asteroids. Could one of those visitors, long before 3I Atlas, have seeded it with the chemistry of life? Could Mars once have blossomed with organisms born not of its own soil, but of cosmic messengers? If so, perhaps 3I Atlas is not a beginning, but a reminder, a new chapter in as old as the stars themselves. As 3I Atlas continues its fleeting passage, the Mars connection forces us to confront a profound truth. Planets are not isolated. They are part of a cosmic ecosystem, connected by the wanderings of objects that pay no heed to borders. Mars, often called a dead world, may yet find itself renewed by the touch of an interstellar traveler. Whether that touch brings life, mystery, or simply wonder, it ensures that Mars's story is forever intertwined with the stars beyond. In the end, the Mars connection is less about mathematics and more about meaning. An alien rock traveling for eons happened to sweep close to a world that has always stirred humanity's imagination. That coincidence alone feels like a message that we are part of a universe in motion, that planets are not alone, and that even in silence, the cosmos speaks. And Mars, sitting red and waiting beneath the passage of 3 Atlas, may one day hold the answers we have been searching for all along. Potential for impact or capture. When scientists calculated the trajectory of 3I Atlas, they realized almost immediately that its hyperbolic path made a direct collision with Mars highly improbable. The object was moving far too quickly, with an interstellar velocity that would carry it past the sun's grip and on into the void. Yet the story does not end there. In celestial mechanics, impact and capture are not binary outcomes, but shades of probability influenced by countless variables: gravity, debris trails, outgassing jets, and the fine dust particles a comet-like body may shed as it warms near a star. And in this delicate interplay, Mars finds itself in an intriguing position. The first possibility, of course, is impact. While the core body of 3I Atlas was never expected to collide with Mars, the same could not be said for the cloud of fragments, dust, and gases it shed during its passage. Comets and interstellar objects are rarely solid monoliths. They fragment, fracture, and release plumes of material as ices sublimate under solar radiation. Even a modest release of debris could scatter a wide fan of particles across space, and if Mars happened to be in the right place at the right time, it could sweep through that material like a net dragging through cosmic waters. Impact on Mars need not mean a catastrophic strike. More likely, it would manifest as micrometeors streaking through the thin Martian sky, bright flashes above the deserts and polar caps. Unlike Earth, with its thick blanket of atmosphere, Mars would allow more of these particles to reach the surface intact. A grain of carbon-rich dust, smaller than a speck of sand, could embed itself into Martian soil and remain there, preserved in the silence of the planet's environment. For astrobiologists, this possibility is tantalizing. Each fragment would represent an alien fingerprint, chemistry born around another star, deposited onto a world humanity already dreams of exploring and colonizing. But what if larger fragments were involved? Even a modest rock a few meters across could produce a visible crater. Mars is already scarred with countless impact sites, reminders of a violent history. A fresh crater caused by a fragment of 3I Atlas would stand apart, not just another piece of the solar system, but a visitor from beyond. Scientists imagine the scenario: a small strike releasing a puff of dust into the air, the Perseverance rover's instruments detecting a chemical anomaly, future astronauts stumbling across a newly formed pit with strange minerals never before cataloged in our solar system. Such a discovery would instantly transform the way we view planetary geology and interstellar migration. And then comes the more exotic scenario: capture. While unlikely, the idea has fascinated astronomers and the public alike. Could Mars, with its gravity well, snare a fragment of 3I Atlas and hold it in orbit, even temporarily? The mathematics is unforgiving. For capture to occur, energy must be dissipated. An object moving at interstellar speeds cannot simply fall into orbit without some mechanism to bleed away velocity. On Earth, this can sometimes happen through atmospheric braking, A meteor slows dramatically as it burns. Mars, with its thin air, offers only a faint version of this effect. Still, for dust or pebble-sized particles, the atmosphere could slow them enough to settle onto the surface. Larger fragments, if passing at just the right angle, might even skim the upper air, shedding energy before either bouncing back into space or falling into a shallow orbit. Another mechanism is gravitational interaction. If a fragment passed close enough to one of Mars's moons, Phobos or Deimos, it could be nudged into a different trajectory. Phobos, in particular, orbits so close to Mars that its gravitational sphere of influence overlaps with the planet's atmosphere. A fragment brushing through this chaotic region might find its energy reduced enough to linger. Even a temporary capture, a fragment circling Mars for weeks or months before spiraling down, would represent a profound scientific opportunity. Imagine a foreign rock from interstellar space becoming, for a brief moment, Mars's third moon. Theoretical though it may be, such possibilities spark enormous interest. If even a fragment were captured or deposited intact, it would mean that Mars hosts a physical sample of interstellar material. Missions could one day recover it, allowing humanity to study chemistry from another star without ever leaving the solar system. Unlike comets formed in our Oort cloud, these samples would not just be ancient, they would be alien, built under different stellar conditions, carrying isotopic ratios that could rewrite our models of planet formation across the galaxy. But there are risks too. Mars is not just a scientific laboratory, it is also the centerpiece of humanity's colonization dreams. If a fragment from 3I Atlas carried unfamiliar compounds, they could interact with Mars in ways we cannot predict. Toxic molecules could seep into the soil. Reactive chemicals could alter the planet's already delicate atmosphere. If microbial life exists within Mars, dormant beneath the surface, alien compounds could disrupt or even erase it. In the most extreme and speculative scenarios, 3I Atlas could even bring simple, self-replicating structures, primitive prebiotic molecules that act as seeds for life. If introduced into Mars's hidden aquifers, they might compete with any indigenous biochemistry. In that case, the interstellar connection would not be a gift, but a contamination, forever altering what it means to search for Martian life. Some scientists view this as less a threat than a reminder of how the universe works. Impacts and captures are not exceptions, they are the rule. Planets grow, evolve, and sometimes bloom with life precisely because they are bombarded by material from elsewhere. Earth itself may have received its water from comets, and perhaps the spark of life from interstellar grains. If Mars is touched by 3I Atlas, then it is participating in the same cosmic exchange. Whether beneficial or harmful depends on perspective. To the planet, it is simply another chapter in an ancient story of collisions. To humanity, it may be an unparalleled chance to witness panspermia in action. There is also the symbolic weight of such an event. Throughout history, cultures have linked Mars to conflict, destiny, and transformation. A celestial visitor depositing fragments on its surface echoes myths of gods, casting down fiery stones or messengers from the heavens, reshaping the fate of worlds. Even in modern times, the narrative persists. If future colonists discover alien chemistry in Martian soil, the story will not only belong to science, it will belong to our imagination, to the sense that Mars was chosen to be marked by a traveler from the stars. For now, astronomers watch carefully. Telescopes measure the fading glow of 3I Atlas as it recedes, while rovers on Mars continue their search for anything unusual in the dust. Most likely, the passage will leave only a faint trace, perhaps invisible to our instruments, but the possibility lingers. In every meteor streak, in every grain of soil sifted by a robotic arm, there could be evidence of a connection too fleeting to fully grasp. Impact or capture need not be dramatic. Even the smallest deposit could one day change the way we think about life, origins, and the destiny of planets. The potential for impact or capture is not just about physics, it is about possibility. It asks us to imagine what happens when a wanderer from the galaxy brushes close to a world we have always dreamed of calling our own. Will Mars remain untouched, its story unaltered? Or has it already been marked, forever changed by a gift or a warning from the interstellar dark? Until we know for certain, Mars will stand as both witness and participant in this mystery, carrying within its red sands the potential legacy of 3 Atlas. comet chemistry and organics. When astronomers first pointed their instruments toward 3I Atlas, they hoped to catch more than just its brightness and trajectory. What they wanted most was to understand its chemistry, the invisible fingerprints of the molecules it carried. For centuries, comets have been thought of as time capsules, frozen remnants of planetary systems that preserve the conditions of their birth. But 3I Atlas was something different. It was not born of our sun, it came from another star, a place no probe has yet reached. That meant its chemistry could offer us a glimpse into the diversity of cosmic building blocks scattered across the galaxy. The first measurements, though faint and challenging, revealed intriguing hints. Unlike many comets within our solar system, which release vast plumes of water vapor when heated by sunlight, 3I Atlas seemed rich in carbon dioxide and other volatile gases. Spectral data suggested the presence of organic molecules, compounds made of carbon, hydrogen, oxygen, and nitrogen. These are the raw ingredients of life as we know it. While scientists stopped short of declaring that 3I Atlas carried anything alive, the chemistry itself was enough to stir imaginations. If even a small fraction of interstellar objects are like this one, then the galaxy could be filled with the seeds of biology. To understand why this matters, one must first appreciate the role comets have played in theories about life's origins. On Earth, many scientists believe that early impacts from comets and asteroids delivered water and organic molecules that were not abundant on the young planet. These cosmic messengers enriched the surface with amino acids, sugars, and other simple compounds that eventually combined into the first living cells. This theory, known as panspermia, suggests that life's essential chemistry is not confined to one world but shared across many, spread like dandelion seeds on the wind of space. If 3I Atlas carries similar compounds, it would strengthen the idea that the galaxy itself is a garden, and every comet a potential gardener. What makes 3I Atlas especially important is its alien nature. Comets from our Oort cloud or Kuiper belt all formed in the same stellar nursery as Earth. Their chemistry reflects our own star's recipe. But an interstellar comet is a visitor from elsewhere. Its ratios of isotopes, different versions of atoms, could reveal how stars of different sizes and ages shape their planets. For instance, the balance between carbon-12 and carbon-13, or between hydrogen and its heavier isotope deuterium, can act as a signature of where and how a body formed. If scientists could measure these ratios in 3 Atlas, they might find fingerprints of a stellar nursery entirely unlike our own. Even without such precise data, the hints of carbon-rich chemistry sparked wonder. Carbon is the backbone of organic molecules because it can form long, stable chains and rings, bonding with hydrogen, oxygen, and nitrogen to create incredible complexity. In Earth's oceans, these simple compounds assembled into proteins, lipids, and nucleic acids, the machinery of life. If 3I Atlas harbors even the simplest versions of these molecules, it demonstrates that the galaxy is predisposed toward complexity. Life may not be rare, it may be inevitable wherever chemistry is given enough time. Mars, of course, enters the story again. If fragments or dust from 3I Atlas fall upon its surface, they will mix with a world already rich in its own mysteries. Mars has shown traces of organic molecules before, detected by rovers like Curiosity and Perseverance. But scientists have always struggled to determine whether those molecules formed locally or were delivered by impacts. With 3I Atlas in the picture, another possibility arises, that some of Mars' organics may come from beyond the solar system altogether. Imagine standing on the red sands and knowing that the molecules beneath your feet were born under an alien star billions of years ago. It would make Mars not just a neighbor planet, but a crossroads of galactic chemistry. There is also the tantalizing possibility that interstellar comets carry more than just simple compounds. In 2020, scientists analyzing meteorites discovered amino acids, basic building blocks of proteins, frozen inside them. Other studies have suggested that sugars and even precursors to nucleobases, the elements of DNA and RNA, can form naturally in space under ultraviolet radiation. If these complex molecules can arise spontaneously in the icy shells of comets, then 3I Atlas could carry them as well. That means its dust might not just represent potential, but a fully stocked chemical toolkit for life. Yet mysteries remain. Why did 3I Atlas show such a faint tail compared to its carbon-rich chemistry? Normally, volatile gases escaping a comet create a bright coma and a long tail stretching across millions of kilometers. But in this case, the activity was subtle, almost muted. Some astronomers suggest that its surface might be coated with a crust of refractory materials, rocky dust that traps gases inside. Others propose that its composition is simply unlike anything we have seen before, shaped by conditions alien to our solar system. Whatever the answer, it underscores how little we know. For those who dream of interstellar travel, 3I Atlas serves as a messenger. If humanity ever ventures beyond the solar system, it may find worlds built on different chemistries, with elements balanced in ways we cannot yet imagine. Some of those worlds may be barren, others may be fertile in ways that challenge our understanding of biology. This comet, passing silently near Mars, may already carry evidence of such diversity. It is a sample return mission from another star, delivered not by rockets, but by the random drift of the cosmos. Culturally, the discovery of organics on an interstellar object resonates with ancient myths. Many traditions speak of life as a gift from the heavens. In Polynesian lore, stars were seen as guiding spirits that shaped the world. In Greek mythology, Prometheus carried fire from the gods to humanity. In modern science, comets may play the role of cosmic Prometheus, bringing the fire of chemistry to barren planets. The narrative writes itself, a frozen traveler, older than human civilization, carrying the seeds of life across the void, brushing past Mars as if to remind us that we are not isolated, but part of a larger network of creation. Yet the darker interpretation cannot be ignored. If comets can carry life's ingredients, they can also carry hazards. Complex organics may include compounds toxic to humans or disruptive to ecosystems. For future Mars colonists, an environment altered by alien chemistry could pose risks we do not yet understand. What if dust inhaled through a leaky helmet carried molecules that interfered with human biology? What if crops grown in Martian soil absorbed compounds that destabilized their proteins? These concerns may sound speculative, but they echo the lessons of Earth, where invasive species can devastate ecosystems not prepared for them. In space, the stakes are even higher. Still, the balance of wonder outweighs the fear. The presence of organics on 3 Atlas underscores the idea that life is not unique to Earth. It is written into the fabric of the galaxy. Each interstellar comet may carry a piece of that truth. And by passing close to Mars, this one has invited us to witness it firsthand. In the end, the chemistry of 3I Atlas is more than science. It is a story of origins, possibilities, and connections across unfathomable distances. If Mars receives even a dusting of its organics, then one day, perhaps centuries from now, humans exploring the red planet may hold in their hands a fragment of a story that began light years away. A story not of Earth, not of Mars, but of life's universal potential. And that possibility, the idea that comets like 3I Atlas are not just wanderers, but carriers of destiny, may truly change how we see Mars forever. Could it seed Mars with life? From the moment astronomers confirmed that 3I Atlas contained carbon-rich compounds, the most profound question emerged almost inevitably. Could this interstellar traveler seed Mars with life? The very idea treads the boundary between science and speculation, but it is rooted in a theory that has lingered for more than a century: panspermia. This hypothesis suggests that life, or at least its precursors, can travel between worlds, hitching rides on comets, asteroids, or interstellar dust. If true, then 3I Atlas is not just an exotic visitor from another star system. It could be a gardener of new worlds. The possibility begins with chemistry. Life as we know it requires carbon-based molecules, water, and energy. On Earth, comets are thought to have delivered much of the organic material that eventually gave rise to biology. Amino acids have been detected in meteorites, and laboratory experiments have shown that the ultraviolet radiation of space can produce sugars and nucleobased precursors inside comet-like ices. If 3I Atlas carries even a fraction of these compounds, then a dusting of its material onto Mars could enrich the red planet's barren surface with alien ingredients. The thin Martian atmosphere makes this scenario even more intriguing. On Earth, incoming meteors burn up as spectacular fireballs, destroying delicate molecules in the process. Mars, by contrast, offers little resistance. Its sky is so thin that even small fragments from space reach the ground largely intact. If grains of 3I Atlas drifted into Mars's orbit, many of them could land softly, embedding themselves into the regolith or sinking into polar ice. Imagine those molecules resting in Martian dust, preserved for ages until conditions allowed them to react. The idea is not far-fetched. In Antarctica, researchers have found micrometeorites carrying intact amino acids. Why should Mars not host the same, especially after an encounter with an interstellar comet? But seeding life requires more than delivering molecules. It requires the right environment to nurture them. Here the question becomes more complicated. Mars is cold, dry, and hostile today, but it was not always so. Billions of years ago, it hosted rivers, lakes, and perhaps even oceans. Even now, it retains subsurface aquifers of salty water, buried beneath layers of ice and rock. These hidden reservoirs are shielded from radiation and may maintain liquid conditions favorable for chemistry. If 3I Atlas deposits its cargo of organics, those molecules could eventually seep into these aquifers. In such places where liquid water persists, reactions could take hold, building complexity molecule by molecule. Over centuries or millennia, something resembling life might emerge. Some scientists argue that this has already happened countless times. They point out that Earth, Mars, and Venus were bombarded heavily during the early solar system's chaotic youth. Countless comets crashed onto their surfaces, spraying volatile compounds into their skies and soils. If panspermia is real, life could have sparked on Mars long before Earth, or vice versa, with microbes potentially swapping between planets via impact ejecta. If so, then 3I Atlas is simply another chapter in a cosmic story as old as the solar system itself. It would not be the first to deliver life's ingredients to Mars, but it may be the first we've witnessed with our own eyes. Yet the concept raises unsettling questions. If Mars already hosts dormant or hidden microbes, would alien organics from another star disrupt them? Could new chemistry overwrite old biology? Earth's history provides a cautionary tale. When ecosystems encounter invasive species, the results can be catastrophic. In cosmic terms, the introduction of foreign chemistry could reshape Martian evolution in ways we cannot predict. Some see this as contamination, a kind of biological trespass. Others argue that such mixing is inevitable, that planets are not isolated laboratories, but participants in a galactic exchange. Life, in this view, is not fragile. It is opportunistic, ready to flourish wherever conditions permit, regardless of origin. For future colonists, the implications are staggering. Human missions to Mars will rely on agriculture, recycling, and careful management of resources. If 3I Atlas has delivered unfamiliar molecules, colonists may unknowingly encounter them in soil or water supplies. These compounds could prove beneficial, perhaps enriching Martian soil in unexpected ways, making crops grow more easily. Or they could be harmful, producing toxins or interfering with human biology. Either way, colonists would not be settling on a pristine world, but one that has been touched by chemistry from another star. There is also the philosophical dimension. If life were to emerge on Mars after being seeded by 3I Atlas, what would it mean? Would that life be Martian or alien? Would it belong to Mars, to the comet, or to neither? Such questions blur the boundaries of identity and origin. Perhaps life is not a local phenomenon at all, but a universal process unfolding wherever conditions align. In that case, 3I Atlas is not a random rock. It is a reminder that the galaxy itself is fertile. Ancient cultures would have interpreted such an event differently. To the Babylonians, Mars was the star of war, a symbol of conflict and fate. To the Greeks and Romans, it embodied gods of blood and iron. A fiery visitor streaking across its sky would have been seen as an omen of transformation. In modern times, we replace omens with data, yet the sense of awe remains. If 3 Atlas has truly sown seeds on Mars, it would be nothing less than a myth made real, a heavenly messenger changing the destiny of a planet. Skeptics, however, urge caution. Organic molecules alone are not life. They are necessary, but not sufficient. Chemistry must cross a vast gulf of complexity to become biology, and there is no guarantee that Mars provides the right spark. It is entirely possible that 3I Atlas has delivered molecules that will sit inert in the soil, never rising beyond potential. For life to flourish, energy sources are crucial: heat, chemical gradients, radiation shielding. Without them, organics remain only frozen relics of possibility. Still, the mystery persists. Future missions may yet reveal traces of 3I Atlas within Martian samples. If a rover or human explorer uncovers molecules with isotopic ratios unlike anything in the solar system, we will know that the red planet has been seeded by another star. Whether those molecules remain chemical curiosities or become the foundation of new life will depend on Mars itself. But even in the absence of biology, the discovery would change everything. It would confirm that interstellar objects can and do deliver complex organics across vast distances. It would mean that every star system is not just a set of planets, but a participant in a galactic network of chemical exchange. The question, could it seed Mars with life, is not just scientific, it is existential. If the answer is yes, then life is not a rare accident confined to Earth. It is a pattern, repeated across time and space, carried by wanderers like 3 Atlas. And if the answer is no, if Mars remains barren despite receiving these gifts, then the miracle of life on Earth shines even brighter, a fragile exception in a universe of silence. Either way, the comet has forced us to confront the possibility that Mars's future is not entirely its own. Its destiny may be shaped not only by human exploration, but by the cosmic messengers that pass across its skies. In that sense, 3-eyed Atlas has already changed Mars forever, not because it certainly seeded life, but because it reminded us that it could. And that possibility, hovering between wonder and fear, is enough to redefine how we see both Mars and ourselves. Comparison with Earth's history. When scientists looked at the chemistry and path of 3I Atlas, they could not help but compare it with the long and mysterious history of our own planet. For Earth, the arrival of comets, asteroids, and interstellar debris has never been just a sideshow. It has been central to the story of life itself. To understand what 3I Atlas could mean for Mars, we must look back to Earth's ancient past and ask how much of what we are today was shaped by similar encounters. In its infancy, Earth was a violent world. 4.5 billion years ago, the young planet was a molten sphere, battered by constant impacts. Water, if it existed, boiled away under relentless heat. Life seemed impossible. Yet as Earth cooled, comets and asteroids continued to strike, delivering not only more destruction, but also the ingredients of transformation. Many researchers now believe that Earth's oceans themselves may have been filled, at least in part, by icy comets. Trapped within those frozen bodies were not only water molecules, but also carbon dioxide, methane, ammonia, and organic compounds, the same kinds of chemistry now hinted at in 3 Atlas. This bombardment period, sometimes called the Late Heavy Bombardment, lasted hundreds of millions of years. It was chaotic, but out of that chaos came the conditions necessary for biology. Meteorites that have fallen to Earth, even in modern times, carry amino acids, the fundamental building blocks of proteins. In laboratory experiments, these molecules can combine under the right conditions to form more complex chains, edging closer to the machinery of life. If Earth's history is any guide, then the material carried by 3I Atlas is not trivial dust. It is potential. Potential for chemistry to become biology, potential for barren worlds to become living. The comparison deepens when we consider timing. Earth's earliest evidence of life, carbon isotopes in rocks, stromatolite-like structures, microfossils, appears remarkably soon after the bombardments ended. Within a few 100 million years of Earth stabilizing, life was already flourishing in the oceans. This rapid emergence suggests that once the ingredients are in place, life is less a miracle and more an inevitability. If comets like those that seeded Earth played a decisive role, then 3I Atlas brushing past Mars today is part of the same universal process. It is as though the cosmos replays its experiments again and again across worlds and epochs. But Earth's story also warns us. Impacts can both create and destroy. The same celestial messengers that brought life's ingredients have also caused mass extinctions. 66 million years ago, an asteroid struck what is now the Yucatan Peninsula, triggering the extinction of the dinosaurs and reshaping ecosystems worldwide. The chemistry delivered that day was less important than the violence. In that sense, Earth's history shows us the dual nature of these visitors. They are carriers of life and agents of death, reminders that evolution is not only about creation, but also about survival through catastrophe. If 3I Atlas had been aimed at Earth instead of Mars, the discussion today might not be about life's potential, but about humanity's fragility. And yet, Earth's resilience is striking. After every mass extinction, life has rebounded, often with greater diversity than before. This resilience is possible because the building blocks, carbon, water, organics, are so deeply embedded in the planet's environment. Each impact, even the catastrophic ones, stirs the pot of chemistry, sometimes sterilizing regions, sometimes enriching them, always reshaping the possibilities for evolution. In this light, 3i Atlas is not a threat, but a reminder of the universe's creativity. On Mars, it could act as a spark, nudging a dormant or barren world toward new potential, just as Earth was nudged billions of years ago. There is also the question of isotopic fingerprints. Earth's water carries a specific ratio of hydrogen to deuterium, a heavier isotope. When scientists measure this ratio in comets and meteorites, they find both similarities and differences. Some comets match Earth's water closely, supporting the idea of a shared origin. Others differ, suggesting multiple sources contributed. If fragments of 3i Atlas ever fall to Earth or Mars, their isotopic signatures could confirm whether life's building blocks are universal across the galaxy or unique to each star system. If the ratios are similar, it would suggest that the chemistry of life is written broadly across the cosmos. If they are different, it would mean that Earth's version of life is one variation among countless possible recipes. Earth's history also shows us the importance of environment in shaping outcomes. Delivered organics alone did not create life. They needed oceans, energy sources, and stable conditions to thrive. Lightning, volcanic heat, hydrothermal vents, these provided the catalysts for complexity. On Earth, deep-sea vents offered ideal settings where hot, mineral-rich fluids met cold seawater, creating gradients that powered primitive chemistry. Could Mars offer anything similar today? Its subsurface aquifers, if warmed by geothermal activity, might provide an analog. If so, then 3i Atlas depositing organics onto Mars could set in motion processes eerily similar to those that unfolded on Earth eons ago. Cultural memory on Earth also mirrors this cosmic story. Many myths describe fire from the heavens, stones that bring fertility or destruction, stars that sow seeds upon the Earth. These myths, born from watching comets blaze across ancient skies, may be echoes of a deeper truth, that humanity has always sensed a connection between celestial visitors and the origin of life. In comparing 3i Atlas with Earth's history, we find not only scientific parallels but also mythic ones. Our ancestors may have intuited what modern science now confirms. The sky is not just distant and empty, but the source of transformation. The philosophical comparison is equally powerful. On Earth, life did not arise in isolation. It arose because the cosmos gave us its gifts: water, organics, and energy. If Mars is seeded now by 3i Atlas, it would mean that life's story is not unique to our planet, but part of a broader cosmic pattern. In this pattern, planets are canvases and comets are brushes, painting possibilities wherever they fall. Earth's history shows us one outcome: oceans, forests, civilizations. Mars's future could show us another, perhaps one still in its infancy, awaiting the right spark. Even if life never takes hold on Mars, the comparison underscores something vital. Earth is a product of cosmic generosity. Without the bombardments, without the chemistry delivered from the stars, we might not exist. Every breath we take is, in a sense, a gift from ancient comets. To see 3i Atlas passing near Mars is to watch the same process extend beyond our own story, as if the universe is reminding us that its creativity is ongoing, not confined to the past. In the end, the comparison with Earth's history does not give us certainty about Mars' fate, but it frames the possibilities. If Earth became living because of comets, then Mars might as well. If Earth endured both creation and destruction through impacts, Mars may face the same. And if Earth's chemistry was enriched by gifts from beyond, then 3 Atlas offers Mars the same inheritance. The lesson is profound. Life on Earth is not an isolated miracle. It is part of a chain of cosmic events that likely repeats elsewhere. By comparing Mars's present with Earth's past, we glimpse a continuum: barren rock, bombardment, chemistry, and eventually biology. 3 Atlas may simply be the next link in that chain. Whether Mars becomes another Earth or remains a silent desert sprinkled with alien molecules, the comparison reminds us of a truth both humbling and inspiring. Our story is not just Earth's story, it is the universe's story, written in dust, ice, and the wanderings of comets between the stars, Mars as a testing ground. Mars has always occupied a special place in human imagination. To astronomers, it is a red dot moving steadily across the heavens, a neighbor that invites questions about worlds beyond our own. To ancient cultures, it was a god of war and fate, a symbol of power and destruction. But in modern science, Mars has become something even more significant, a testing ground for the greatest mysteries of existence. Nowhere else in the solar system offers such a perfect stage for examining how life might arise, survive, or vanish. And with the passage of 3I Atlas, Mars has been thrust once again into the spotlight as the potential laboratory where interstellar chemistry could meet planetary reality. The reason Mars is such a compelling testing ground is its balance between familiarity and difference. Unlike the gas giants, it is a rocky planet with a surface humans can walk on. Unlike the scorching inferno of Venus, its conditions, while harsh, are not entirely alien. Mars is cold, but not impossibly so. Its atmosphere is thin, but still present. Its geology is varied, carved by rivers that once flowed and volcanoes that once erupted with unimaginable force. In many ways, it is Earth's younger, more fragile sibling, frozen in time just as our own world burst into life. That makes it the perfect case study. If we want to know whether 3I Atlas could deliver the seeds of life, Mars gives us a testbed without the noise and complexity of Earth's biosphere. For scientists, this is critical. Earth is teeming with biology, making it almost impossible to separate indigenous chemistry from contamination. Mars, by contrast, is a blank slate. If organic molecules from 3I Atlas were to land on its surface or seep into its icy soils, their effects could be studied without interference from thriving ecosystems. This makes Mars a natural control experiment. What happens when alien chemistry interacts with a planet that is neither dead in the absolute sense, nor alive in the way Earth is? Already, Mars has shown itself capable of hosting organics. NASA's Curiosity rover detected complex carbon compounds in 2018, preserved in ancient sediments. Perseverance has since collected samples that hint at organic chemistry more widespread than once thought. Yet the origin of these compounds remains debated. Did they form within Mars itself through geological processes? Were they delivered by comets and asteroids long ago? Or do they represent something even stranger, an ancient biosphere now reduced to traces? Adding 3I Atlas into the mix creates an extraordinary opportunity to watch in real time as new material from beyond the solar system becomes part of the Martian environment. If Mars is indeed dusted with fragments of 3I Atlas, it becomes a kind of cosmic petri dish. Scientists can ask whether those molecules persist in the harsh ultraviolet radiation of the thin Martian sky, or whether they break down quickly. They can ask whether the compounds remain inert, or whether they interact with perchlorates, salts abundant in Martian soil, to form new chemistry. In Earth laboratories, researchers already simulate these conditions, exposing organic molecules to cold, dry, oxidizing environments. But to see it happen on Mars itself with authentic interstellar chemistry would provide the ultimate experiment. Even more intriguing is the question of subsurface habitability. Mars's surface may be hostile, but beneath the ice and rock, liquid water likely exists in briny reservoirs. These aquifers are stable, shielded from radiation, and potentially warmed by geothermal activity. If molecules from 3I Atlas manage to migrate downward through dust storms, melting ice, or slow geological cycling, they could find themselves in environments not unlike Earth's early oceans. In such places, chemical gradients provide the energy for reactions, and over long spans of time, complexity can emerge. Mars thus becomes not just a test for the survival of alien organics, but a proving ground for whether life can actually begin anew under conditions far different from Earth's. For human exploration, this role as a testing ground has practical importance as well. Future missions plan to send astronauts, habitats, and agriculture to Mars. One of the greatest questions facing colonization is whether Mars can sustain biological systems imported from Earth. Can crops grow in Martian soil, or must we rely entirely on hydroponics? Can microbes recycle waste and maintain closed ecosystems, or will they be poisoned by local chemistry? If 3I Atlas has delivered organics, those molecules could subtly alter the answers. Perhaps Martian soils enriched by alien carbon compounds will prove more fertile than expected. Perhaps they will present new challenges, introducing unknown variables into human biology. In either case, Mars serves as the proving ground where we will discover whether humanity can adapt to life beyond Earth. The symbolic resonance is striking. Earth was once seeded by comets, which helped transform it from a sterile planet into a living one. Now, as humanity prepares to step onto Mars, a new interstellar comet arrives, offering the possibility of a second seeding. It is as though history is repeating itself on another stage, with humans present this time to watch. Mars becomes the experiment we can observe in real time, the chance to see whether life's story is unique to Earth or part of a universal pattern. But the testing ground is not only for life's origins, it is also for life's limits. Mars teaches us how fragile and resilient biology can be. Even if 3 Atlas delivers the richest chemistry imaginable, it may still wither in the Martian cold, sterilized by radiation, unable to progress. That result would be just as important as success. It would show that not every planet is capable of nurturing life, even with the right ingredients. It would highlight the uniqueness of Earth, reminding us that our biosphere is a rare triumph in a hostile cosmos. In this way, Mars tests not only panspermia, but also the boundaries of life's adaptability. The cultural implications are equally powerful. Ancient mythologies often described Mars as a place of trial and transformation. To the Romans, it was the god of war, demanding strength and resilience. To modern humanity, it is a proving ground in a different sense, the place where we test our technology, our courage, and our ability to extend life beyond Earth. With 3 Atlas brushing near, Mars becomes a stage for the cosmos itself to contribute to that test. The comet offers a question written in dust and ice. Can alien chemistry find a foothold on another world, just as it once did on ours? Some might argue that Earth itself should remain the focus, that searching for life in Martian soil or worrying about alien dust is secondary to protecting our own planet. But in truth, Mars allows us to test questions we cannot ask here. On Earth, life is everywhere. Even the deepest ocean trenches and the driest deserts teem with microbes. Any experiment in primordial chemistry is contaminated before it begins. Mars is different. It is clean, simple, austere. If organics from 3I Atlas can persist or thrive there, the evidence will be unambiguous. Mars is, in that sense, the closest thing we have to a cosmic laboratory, one provided not by human design, but by the universe itself. Ultimately, Mars as a testing ground is not about certainty, but about possibility. The red planet stands between life and death, between barrenness and fertility, between past and future. If 3 Atlas leaves even the faintest trace upon it, Mars will become the site of one of the most profound experiments ever conducted, not by human hands, but by the cosmos. The results may take decades or centuries to unfold, but the question has already been asked silently in the meeting of comet and planet. Mars is where we will learn whether life is a fluke of Earth or a principle of the universe. It is where humanity will test not only its machines, but its very understanding of what it means to be alive in a galaxy filled with wanderers like 3I Atlas. And in that role, as a testing ground, Mars may prove to be the most important planet in human history after our own. Dust and debris fields. When astronomers tracked the passage of 3I Atlas, they understood that the main body would sweep through the solar system too quickly to be captured by the Sun or by Mars. But they also knew that interstellar objects are rarely solitary in their journey. As they heat up, they shed material, dust grains, icy fragments, volatile gases, that fan out into vast fields trailing and surrounding them. These dust and debris fields may not be as visible as a bright comet's tail, but they can linger in space long after the parent body has passed, drifting across planetary orbits and quietly altering environments they touch. For Mars, the prospect of 3I Atlas leaving behind such fields was one of the most intriguing and potentially consequential aspects of its encounter. Dust is far more than cosmic clutter. Each grain is a microscopic time capsule, preserving the chemistry of its parent body. In the case of 3I Atlas, those grains may have formed around a distant star billions of years ago, holding within them isotopic ratios and organic compounds unlike anything in the solar system. By passing near Mars, these grains could rain down through its thin atmosphere, embedding themselves in the regolith, mixing with ice at the poles or drifting in the winds of dust storms that already shape the planet's climate. In this way, 3I Atlas might leave a signature far more lasting than the fleeting glow of its cometary core. The effects of debris on Mars's atmosphere are especially compelling. Even tiny particles can catalyze chemical reactions when they interact with sunlight or the planet's carbon dioxide-rich air. On Earth, meteoric dust contributes to the formation of noctilucent clouds at high altitudes. On Mars, similar interactions could seed clouds in ways not yet observed, changing patterns of weather or creating new layers of haze that alter how heat escapes into space. Though subtle, such effects could last for months or years, providing scientists a natural experiment in how interstellar material influences planetary climates. More dramatic possibilities lie in micrometeorite impacts. As Mars crosses paths with debris from 3I Atlas, grains moving at tremendous speeds could strike the surface, releasing flashes of energy. These impacts, invisible to the naked eye from Earth, might be detected by orbiting satellites as brief thermal events. Over time, they would pepper the surface with microscopic craters, each one a tiny scar left by a traveler from another star system. Rovers on Mars might one day stumble upon such sites, analyzing their chemistry and finding signatures distinct from native Martian minerals. For planetary scientists, this would be like discovering letters from a distant civilization, written not in language but in isotopes and molecules. The polar regions of Mars may be the most important repositories of this debris. The ice caps, layered over millions of years, record a history of dust storms, volcanic eruptions, and climate shifts. If 3I Atlas has indeed contributed particles, they could become embedded in these icy strata, preserved like fossils for future explorers to uncover. Imagine drilling into Martian ice centuries from now and finding a layer rich in carbon-rich dust, identifiable as interstellar by its unique isotopic fingerprint. Such a discovery would not only confirm the comet's contribution, but also demonstrate that Mars has preserved a physical archive of cosmic visitors. For astrobiologists, the key question is whether debris from 3 Atlas could influence the search for life. Dust fields are not just inert matter. They can carry amino acids, sugars, and other prebiotic compounds. If deposited on Mars, these could become part of the soil chemistry, interacting with perchlorates and sulfates to create new compounds. Some of these reactions might even produce energy, offering niches where microbes, if they exist, could exploit them. In this way, debris from 3I Atlas could act as both food and fertilizer for hypothetical Martian life. Even if no biology exists, the new chemistry might set the stage for it in the distant future, enriching the planet's potential as a cradle for life. But there are risks to this influx of alien material. Mars's surface chemistry is already puzzling, with rovers detecting strange variations in methane concentrations and unexpected patterns in organic molecules. If debris from 3I Atlas alters the chemical environment, it could confuse efforts to interpret these signals. Future scientists might detect unfamiliar organics and mistakenly attribute them to ancient Martian biology when in fact they came from a comet millions of kilometers away. This contamination problem highlights the double-edged nature of debris fields. They can reveal cosmic processes, but they can also obscure the truths we seek. The scale of debris fields also makes them significant for human exploration. A planet constantly crossing paths with interstellar dust may face hazards for spacecraft and habitats. Fine grains moving at high speeds can damage surfaces, degrade solar panels, and puncture delicate structures. For colonists on Mars, even small increases in micrometeorite activity could pose long-term challenges. Protective shields, careful monitoring, and adaptive technologies may be needed to ensure survival in a world touched not only by local storms, but by interstellar visitors. At the same time, debris fields could be resources. If Mars were seeded with rich deposits of carbon, nitrogen, and other valuable compounds, colonists might mine them for use in agriculture, industry, or fuel production. A single micrometeorite rich in volatile gases could offer insights into chemical processes unavailable elsewhere. Over time, harvesting alien dust might even become a routine part of Martian colonization, transforming cosmic debris into building blocks for survival. Comparisons with Earth provide context. Our planet constantly sweeps through dust streams left by comets, producing meteor showers like the Perseids or Leonids. These showers are beautiful but also scientifically significant, delivering small amounts of extraterrestrial matter to Earth's surface every year. Mars, lacking Earth's thick atmosphere, would experience these events differently, with more material reaching the ground intact. 3I Atlas could therefore leave behind not just fleeting showers, but permanent contributions to Martian geology. Just as Earth's oceans may have been enriched by cometary dust billions of years ago, Mars's regolith could be enriched today by an interstellar source. Culturally, dust and debris carry symbolism as well. In many traditions, dust is associated with beginnings and endings, ashes to ashes, dust to dust. To imagine Mars being sprinkled with dust from another star is to imagine it being given a new beginning, a fresh layer of possibility. Ancient peoples might have seen such an event as divine intervention, a blessing or warning from the heavens. In our scientific age, we interpret it as chemistry and physics, but the sense of wonder is no less. The thought that every grain of dust could carry the memory of another star system transforms a barren desert into a cosmic canvas. In the end, the dust and debris fields of 3II Atlas may prove more influential than the comet itself. The core will pass quickly, never to return, but the grains it leaves behind could remain on Mars for millennia, slowly mixing with soil, ice, and air. They may shape the chemistry of the planet, alter its climate, and even influence the search for life. For humanity, they provide both a challenge and an opportunity to learn from these microscopic messengers, to adapt to their presence, and to recognize that even the smallest fragments of the cosmos can carry immense meaning. The dust of 3 Atlas is more than matter. It is memory, possibility, and connection. By scattering across Mars, it ties the red planet to a star system light years away, reminding us that no world is truly isolated. Every orbit, every encounter, every grain of dust binds the planets into a single story, the story of a galaxy where even the smallest fragments can change the destiny of worlds. Ancient myths and prophecies. For as long as humans have gazed at the night sky, they have woven stories around the sudden appearance of fiery messengers streaking overhead. Comets, shooting stars, and strange wandering lights were rarely seen as random events. Instead, they were interpreted as omens, warnings of catastrophe, heralds of change, or even messages from gods. The arrival of 3I Atlas near Mars echoes this timeless pattern. Though we now speak of trajectories and isotopes, our ancestors would have spoken of prophecy. To them, such a visitor would not have been a passive rock drifting through the heavens, but a sign that the cosmic order was shifting. One of the oldest traditions comes from Mesopotamia, where the Babylonians kept meticulous records of celestial phenomena. Comets were considered portents of upheaval. Their scribes believed that when an unfamiliar star blazed across the sky, it foreshadowed the fall of kings or the rise of empires. A bright visitor near Mars, which they already associated with the god of war, would have been interpreted as a sure sign of conflict or divine intervention. Clay tablets from that time detail the appearance of fiery torches in the heavens, connected to plagues, droughts, or invasions. In that worldview, 3 Atlas would not have been seen as a comet at all. It would have been a cosmic decree written in fire. The Greeks and Romans inherited this tradition, layering their own interpretations upon it. Mars, known as Ares or the god of war, was thought to bring turmoil whenever it shone red in the sky. A comet brushing near Mars would have seemed like the war god's weapon, a fiery spear thrust across the heavens. Roman historians often recorded comets during times of political crisis. The assassination of Julius Caesar, for example, was followed by the appearance of a bright comet that many interpreted as his soul ascending into the heavens. In that cultural lens, 3I Atlas might have been seen as a prophecy of transformation, an omen that Mars, the god of strife, was about to play a new role in human destiny. Eastern traditions provide their own fascinating parallels. In ancient China, comets were cataloged with extraordinary care. The Book of Silk, one of the oldest astronomical texts, includes drawings of comet shapes along with their predicted meanings: famine, war, prosperity, or peace. The Chinese often described comets as broom stars, sweeping away the old order to make way for the new. A comet aligning with Mars could have been interpreted as the sweeping away of conflict, or just as easily, the sweeping in of war. Prophets and astrologers in imperial courts would have debated the meaning endlessly, with the fate of dynasties hanging on their interpretations. Among the Maya and other Mesoamerican cultures, celestial visitors were tied directly to cycles of time and prophecy. The Maya believed that the heavens were a great clock, and that the movements of stars and comets were part of repeating patterns that governed life on Earth. They often linked fiery signs in the sky with transitions between world ages, moments when creation and destruction met. In such a worldview, Three-Eye Atlas would not have been a random occurrence, but a marker of cosmic renewal, perhaps even the harbinger of a new age in which Mars, the red planet, would play a pivotal role. In the Middle East, prophetic traditions often wove celestial events into divine warnings. Islamic scholars of the medieval period, though steeped in rigorous astronomy, still recorded comets as signs that should be interpreted within spiritual contexts. Jewish texts, too, occasionally speak of stars blazing forth as signals of messianic change. The overlap between rigorous observation and mystical interpretation shows how deeply comets blurred the line between science and prophecy. An interstellar object like Three-Eye Atlas would have been seen not as neutral, but as a fulfillment of hidden truths. Even within European medieval lore, comets were regarded with fear and reverence. Chroniclers of the 11th century described Halley's Comet as a terror in the sky, predicting calamities that often followed in the form of wars, famines, or natural disasters. When Halley returned centuries later, Enlightenment thinkers tried to dispel the fear by explaining its orbit. Yet even then, many common people whispered of prophecy. The sudden, unpredictable brilliance of such objects always seemed to demand meaning. Had Three-Eye Atlas appeared then, especially in proximity to Mars, it might have been read as a prophecy of bloodshed, conquest, or divine trial. What unites these myths and prophecies is the recognition that comets are wanderers. Unlike planets with their predictable paths, comets seem to arrive unannounced, blazing across familiar skies like strangers at the door. To ancient peoples, this unpredictability meant that they carried purpose. A predictable event, like the rising of the sun, was part of the natural order. But a sudden, fiery star could only mean that the divine was intervening directly. In this way, comets were not just astronomical events, but sacred interruptions. In the modern age, we may smile at such interpretations, but they carry a symbolic truth that resonates even now. We speak of Three-Eye Atlas as carrying the potential seeds of life, or as a messenger from another star system. In doing so, we echo the language of prophecy, though we use scientific metaphors. Instead of saying the gods have sent a sign, we say the universe has delivered organics. Instead of warning of divine wrath, we speak of contamination or colonization. The framework has changed, but the impulse is the same: to see meaning in the sudden arrival of something that does not belong. There is also a curious harmony between myth and modern science when it comes to Mars itself. For thousands of years, Mars has been linked to destiny and struggle. Now, in our scientific age, it is the planet most likely to host humanity's first colony, the site of our greatest challenge and transformation. If ancient prophets claimed that fiery signs near Mars foretold upheaval, perhaps they were not entirely wrong. The upheaval they imagined may not have been war sent by gods, but the struggle of humanity to leave Earth and carve a new existence on a harsh red world. In this sense, Three-Eye Atlas brushing near Mars could be seen as the fulfillment of a prophecy older than writing itself, the prophecy that Mars is central to humanity's fate. It is also worth noting that myths often spoke not only of warnings but of gifts. Comets were sometimes described as carriers of divine fire or knowledge, bringing wisdom or renewal to humankind. Prometheus in Greek myth brought fire from the heavens to humanity. In Polynesian traditions, fiery objects falling from the sky were sometimes seen as gifts from the gods. If we now interpret Three-Eye Atlas as a bringer of organics, of chemistry capable of igniting life, then we are simply translating that myth into scientific terms. The fire of Prometheus becomes the molecules of carbon. The divine gift becomes the potential for biology. The prophecy is the same. Life and transformation come from the sky. Perhaps the most profound lesson of ancient myths and prophecies is not that they were wrong about comets, but that they understood their significance. They knew that such events mattered, even if they could not articulate why. We now have the tools to measure isotopes, track trajectories, and analyze molecules, but the awe remains. When 3I Atlas crossed the solar system, we too searched for meaning, asking whether it could change Mars forever. In that question lies the echo of every prophecy, every myth, every fearful glance upward at a sky suddenly ablaze. The ancients may have seen comets as divine scribes writing the fates of kings. We see them as cosmic gardeners scattering seeds across worlds. Both visions agree on one thing: comets are not ordinary. They are extraordinary interruptions in the fabric of the familiar, carriers of messages, whether divine or chemical. 3I Atlas, with its strange path and rich chemistry, has inherited that role. It is both a scientific mystery and a prophecy fulfilled, reminding us that the boundary between myth and science is not as wide as we think. In the end, the ancient stories remind us of what is at stake. If 3 Atlas truly leaves its mark on Mars, then the old prophecies of fiery messengers bringing transformation may not have been metaphor at all. They may have been intuitions of a truth only now becoming clear, that life, death, and destiny are written in the heavens, carried on the tails of wandering stars. Mars colonization concerns. For decades, the dream of colonizing Mars has captivated scientists, engineers, and storytellers alike. Space agencies and private companies envision cities beneath domes, greenhouses flourishing in the dust, and generations of humans calling the red planet home. Yet for all the optimism, colonization is riddled with uncertainties, dangers, and moral dilemmas. The arrival of 3I Atlas only magnifies those concerns. If an interstellar object has dusted Mars with exotic organics, gases, or minerals, then human settlement may not be stepping into a pristine environment at all, but into a stage already altered by alien chemistry. The possibility raises questions about safety, ethics, and survival that humanity has scarcely begun to address. The most immediate concern is contamination. When astronauts finally set foot on Mars, their presence will alter its environment. Microbes from Earth, no matter how carefully sterilized equipment may be, will inevitably escape. The fear is that Earth life could spread and confuse efforts to determine whether Mars hosts its own organisms. But 3I Atlas complicates this picture further. If it has already delivered organic molecules, or in the most speculative scenarios, primitive replicating structures, colonists may encounter an environment where Earth biology interacts not only with native Martian chemistry, but with alien additions as well. This three-way collision could produce outcomes we cannot predict: new molecules, new hazards, or even the emergence of hybrid forms of life. Health risks for colonists are another pressing issue. Mars is already hostile. Radiation exposure is many times higher than on Earth, the atmosphere is toxic, and dust storms can envelop the entire planet for months. If 3I Atlas debris has introduced unknown compounds, colonists may face invisible threats. Perhaps certain molecules, harmless in small doses, could accumulate in soil or water supplies, interfering with human biology. Perhaps alien carbon chains could mimic terrestrial molecules, disrupting enzymes or DNA. Without long-term testing, colonists might not realize these dangers until symptoms appeared. The very act of breathing Martian dust could expose them to chemistry, unlike anything the human body evolved to handle. Agriculture on Mars also sits at the heart of colonization concerns. A self-sustaining colony cannot rely on constant supply shipments from Earth. Instead, it must grow its own food, recycle its resources, and create closed-loop systems of survival. Soil, even if heavily treated, is a critical resource. If 3 Atlas has left behind organics, they could alter the chemical composition of that soil. On one hand, they might enrich it, making crops easier to grow. On the other, they could introduce toxins or compounds that interfere with plant metabolism. Imagine a greenhouse of crops that grows quickly, only to reveal that fruits and grains contain dangerous residues. Colonists would be caught between starvation and contamination, forced to learn which alien molecules could be tolerated and which could not. From a broader perspective, planetary protection takes on new urgency. International treaties already require that humanity prevent harmful contamination of other worlds. But what does that mean when alien debris has already touched Mars? Colonists may find themselves living not in a purely Martian environment, but in a hybrid one. Protecting that environment becomes a moral puzzle. Should they attempt to preserve any alien chemistry introduced by 3I Atlas, treating it as valuable scientific heritage? Or should they focus entirely on survival, exploiting and altering Mars as they see fit, regardless of what came before? These choices echo old colonial dilemmas on Earth, where new arrivals often reshaped ecosystems without regard for what was lost. There is also the fear of false positives in science. For decades, the central goal of Martian exploration has been to determine whether life ever existed there. If future colonists or rovers detect unusual organic molecules, the natural assumption might be that they represent evidence of ancient Martian biology. But if those molecules actually came from 3I Atlas, then our interpretation would be flawed. The discovery would still be profound. It would prove that interstellar objects deliver life's ingredients, but it would not answer the question of whether Mars itself ever developed life independently. Colonists could find themselves at the center of a confusing debate. Are they discovering Mars, or are they discovering the legacy of an alien comet that passed briefly through the solar system? The risks extend into the psychological and cultural dimensions of colonization. Mars settlers will already be grappling with isolation, confined living quarters, and the harshness of an alien environment. If 3I Atlas introduces the idea that Mars may be chemically or biologically other, colonists may live with constant uncertainty. Is the water safe? Is the air inside the domes pure? Are the molecules drifting through dust storms inert, or do they carry unknown consequences? Living with such ambiguity could erode morale, breeding paranoia, or superstition, much like ancient peoples once viewed comets as omens. In a sense, colonists may relive the mythic awe of their ancestors, seeing the cosmos not only as a frontier, but as an active force in their survival. There is also a more practical concern: resource competition. If interstellar debris has deposited rare isotopes, exotic minerals, or even frozen volatiles on Mars, those resources will become targets of scientific and industrial interest. Spacefaring nations and corporations may not see them as hazards, but as opportunities. Colonists may be pressured to harvest alien deposits for study or profit, even if doing so risks altering Mars's environment or exposing themselves to unknown dangers. The history of Earth shows how resource exploitation often outpaces caution. On Mars, this rush could play out in a far more precarious arena, with lives dependent on fragile systems of support. Yet colonization concerns are not only about threats, they are also about missed opportunities. If humanity rushes to settle Mars without careful study of any alien chemistry left behind by 3I Atlas, we may destroy the very evidence that could answer questions about life's universality. Every greenhouse, every habitat, every dig into the soil risks overwriting the cosmic message left behind. Colonists may inadvertently erase the footprints of interstellar biology before we fully understand them. In this sense, the challenge is not just survival, but restraint, balancing human ambition with the humility to recognize that Mars is not empty. It is part of a living, dynamic cosmos, touched by visitors from other stars. Some futurists argue that colonization must adopt a dual role: survival and stewardship. Colonists cannot simply treat Mars as a blank canvas for human expansion. They must act as guardians of its history, protecting not only potential native life, but also the alien contributions of wanderers like 3 Atlas. This vision casts colonists less as conquerors and more as caretakers of a cosmic laboratory, living within an environment shaped by forces far beyond human control. Whether such a balance is possible remains uncertain. The pressures of survival may outweigh ideals, but the responsibility remains. The symbolism of colonization concerns is profound. Throughout history, humanity has expanded into new frontiers, often with disastrous consequences for ecosystems and peoples already present. Mars offers a chance to learn from those mistakes. Yet, the presence of 3I Atlas complicates that lesson. Colonists may not be alone on Mars, not in the sense of encountering intelligent life, but in the sense of inheriting chemistry from another star system. Their colony would then be not just human, not just Martian, but interstellar. In that case, every decision they make becomes part of a larger narrative, one that ties humanity's destiny to the fate of alien matter delivered across light years. In the end, Mars colonization concerns are not only about practical dangers like radiation or oxygen supply, they are about the unknowns introduced by cosmic visitors like 3I Atlas. Colonists will not just be surviving on Mars, they will be living in a world that has been touched, altered, and perhaps enriched by alien dust. Whether that dust represents opportunity, hazard, or transformation is the unanswered question. But one thing is clear: colonization will not be as simple as planting a flag and building a dome. It will be a delicate dance between survival, exploration, and respect for forces that stretch far beyond human understanding. And so the dream of settling Mars is shadowed by the same mystery that has haunted comets since antiquity. Are they messengers of life or harbingers of danger? For the colonists of tomorrow, 3 Atlas may ensure that the answer lies not in myth, but in their lived reality, signals and anomalies. From the moment 3 Atlas entered the solar system, astronomers and enthusiasts alike turned their ears and eyes toward it, hoping to catch something unusual. After all, when Oumuamua passed through in 2017, it sparked one of the most contentious debates in modern astronomy. Some researchers claimed its peculiar acceleration and shape could be explained by natural processes, while others, most famously Avi Loeb, suggested it might have been artificial, perhaps a probe, a sail, or a fragment of alien technology. When 3 Atlas appeared, the world was ready to scrutinize it with the same intensity, searching for signals and anomalies that might reveal whether it was simply another interstellar rock or something far stranger. At first glance, 3I Atlas looked ordinary, though its faint coma suggested it carried volatile gases and organics. But as telescopes followed its path, subtle anomalies began to emerge. Its light curve, the way its brightness fluctuated as it rotated, did not match expectations for a simple spherical or irregular comet. Instead, the brightness shifts suggested a highly uneven surface or possibly even tumbling motion, as though the body were spinning chaotically rather than smoothly. This was not unprecedented. Many comets tumble. But the precise pattern of brightness variation raised questions. Some researchers noted that it resembled the odd flickering of Oumuamua, which had defied standard models of rotation. Could this be another interstellar object shaped and spinning in ways unfamiliar to us? Then there was the matter of its acceleration. Calculations showed that its trajectory shifted slightly as it passed the sun, more than could be explained by gravity alone. For comets, this is usually due to outgassing, jets of vapor that act like tiny thrusters. Yet 3I Atlas did not show the expected level of activity. Its tail was faint, almost an afterthought, yet the trajectory still exhibited deviations. Were invisible gases propelling it, perhaps composed of exotic ices not commonly seen in the solar system, or was something else altering its course? The discrepancy was small, but it was enough to spark speculation. Radio astronomers joined the effort, aiming their instruments toward 3I Atlas in hopes of detecting signals. SETI, the Search for Extraterrestrial Intelligence, has long argued that interstellar objects passing through our solar system are perfect candidates for listening campaigns. If an advanced civilization were sending probes, they might look exactly like comets or asteroids, blending in until they reached a target system. Though no definitive artificial signals were detected from 3I Atlas, the listening continues to this day. Every spike of radio static, every unexplained burst of frequency is carefully cataloged in case one day patterns emerge that cannot be explained by natural processes. The anomalies extended to chemistry as well. Early spectral readings hinted at unusual proportions of carbon dioxide and organic compounds, different from the ratios seen in most solar system comets. This sparked theories that 3I Atlas may have originated from a system with a very different composition, perhaps orbiting a carbon-rich star. Such anomalies are a reminder that the galaxy is diverse and that each interstellar visitor is a messenger carrying chemical clues from its home. Yet skeptics argue that the data is too faint to be definitive. Are we seeing real differences, or are our instruments straining to interpret signals at the very edge of detection? Anomalies also appeared in the visual data. Some telescopes reported faint glows around the comet, inconsistent with known coma activity. At first, these were dismissed as artifacts of imaging, stray light from stars, or errors in calibration. But others insisted that the glow extended further than expected, perhaps suggesting that 3I Atlas was shedding material in an unusual way. Could the glow represent dust grains of a type not common in our system? Or, as fringe theorists proposed, could it represent a field and energy signature surrounding the body? These claims remain unproven, but they added to the aura of mystery. Mars added another dimension to the anomalies. As 3I Atlas path was plotted near the red planet, researchers speculated that Mars orbiters could detect additional phenomena: shifts in its magnetosphere, bursts of charged particles, or unusual atmospheric chemistry. Mars, with its sensitive instruments and relatively quiet electromagnetic environment, could act like a natural observatory for passing debris. If anomalies were to be detected, Mars be the place where they first became obvious. Some scientists even suggested that Perseverance or older orbiters could record spikes in radiation or chemical traces in the sky during the comet's closest approach. Whether such anomalies have been detected remains an open question, but the idea alone was enough to excite imaginations. Of course, anomalies often invite explanations beyond the scientific. Fringe theorists quickly embraced 3I Atlas as another candidate for artificial origin. Was it a derelict spacecraft launched from a dying civilization eons ago, now drifting helplessly between the stars? Was it a probe deliberately designed to seed other planets with organic material, part of a galactic strategy of directed panspermia? These ideas, while speculative, resonate with a deep human desire to find meaning in the unknown. The anomalies, its brightness, its acceleration, its chemistry, become puzzle pieces that, to some, fit better into a narrative of intelligence than randomness. Ancient prophecy, too, echoes in these anomalies. Civilizations across time often described heavenly visitors as bearing both signs and power. A fiery star whose path shifts mysteriously would have been seen as a willful agent, not a passive stone. Even now, when we cloak anomalies in the language of physics, we feel the same unease. Why does its path deviate so strangely? Why does its brightness flicker with no clear pattern? Why do its molecules not match the recipes of homegrown comets? In each question lies the echo of myth, the suspicion that the heavens are not entirely silent. There is also the unsettling possibility that anomalies are simply our ignorance. Each interstellar visitor is unique, carrying conditions we have never studied before. Perhaps what we call anomalies are just normal in other star systems. What if all comets beyond our sun are rich in carbon dioxide? What if tumbling, flickering rotation is common in bodies forged under different stellar winds? If so, then the anomalies are not signs of artificiality, but reminders of how little we know. Every deviation from expectation forces us to expand our models, to admit that the universe is stranger and more varied than our limited experience suggests. For Mars colonists of the future, these anomalies may not be abstract debates, but lived realities. Imagine a colony monitoring the sky and detecting unexplained fluctuations as a comet passes nearby. Imagine crops or machines reacting oddly to alien dust, showing effects no one predicted. For them, anomalies are not data points in a journal. They are potential crises or opportunities. The way colonists interpret them, whether as hazards, resources, or omens, may determine the course of survival. In the broader sense, signals and anomalies matter because they invite us to listen harder, to look deeper, to question more. When Galileo first turned his telescope to the skies, anomalies abounded. Moons orbiting Jupiter, mountains on the moon, phases of Venus. Each anomaly shattered assumptions and expanded horizons. 3I Atlas may be doing the same. Its flickering brightness, odd acceleration, and strange chemistry may one day be understood as entirely natural. Or they may be the first hints of something extraordinary, evidence that the galaxy is not empty, but alive with travelers who carry more than dust and gas. In the end, signals and anomalies are the language of the unknown. They whisper that not everything is explained, that some mysteries remain. 3I Atlas, like Oumuamua before it, reminds us that the universe still surprises us, still resists our equations. Whether those whispers belong to nature's chaos or to something intentional is a question left open. But for as long as we listen and watch, anomalies will continue to be the sparks that light our imagination. And perhaps one day the clues that reveal our place in a universe far more inhabited than we dared believe. The alien mothership theory. Few ideas ignite the imagination more than the possibility that what appears to be an ordinary celestial object is in fact something extraordinary. A vessel, a probe, or even a mothership from another civilization. When 3I Atlas was detected and its unusual properties began to emerge. Its faint but odd chemistry, its strange acceleration, its peculiar trajectory, some observers could not resist asking the question, what if it is not a natural comet at all? What if 3I Atlas is an alien mothership passing silently through our solar system, perhaps even interacting with Mars? The foundation for this theory lies in precedent, or at least in the debates sparked by Oumuamua, the first recognized interstellar visitor. Unlike ordinary comets, Oumuamua displayed a cigar-like or pancake-shaped profile, a brightness that fluctuated oddly, and an acceleration not fully explained by outgassing. Harvard astronomer Avi Loeb famously suggested it could be a probe, a fragment of alien technology using light sail propulsion. The scientific community largely dismissed the claim, but the idea lodged itself in the public imagination. If Oumuamua could inspire such speculation, then 3I Atlas, with its own set of puzzles, inevitably fueled a similar narrative. Supporters of the mothership theory point to several anomalies. First, its trajectory. 3 Atlas crossed the solar system in a path that aligned closely with the orbits of Earth and Mars, almost as though it were designed to skim the regions most likely to harbor life. Natural objects often plunge in at random angles, but 3I Atlas seemed to move in a way that maximized its interaction with the inner planets. Could this be coincidence? Certainly, but to those who see purpose in patterns, it looked like reconnaissance. Second, its subtle acceleration. As with Oumuamua, 3I Atlas shifted in ways not fully accounted for by gravity. Outgassing is the most conventional explanation, but the lack of a strong visible tail raised questions. Could the object be using propulsion invisible to our instruments, perhaps something akin to solar sails, capturing sunlight to adjust its path? A natural body would drift as dictated by physics, but a mothership could steer, however slightly, correcting its course to ensure it passed close to Mars. Third, its chemistry. Spectral readings hinted at an abundance of carbon dioxide and organic compounds. While comets often contain such material, the ratios were unusual compared to known solar system comets. Some interpreted this as evidence of artificial shielding or engineered design, a way to disguise a craft beneath layers of organic ice and dust. If an advanced civilization wanted to mask its vessel as a comet, wrapping it in frozen volatiles would be an effective camouflage, hiding technology beneath what looks like natural debris. The mothership theory does not stop at the body of 3I Atlas itself. Some theorists suggest that the object may have released smaller probes as it passed. If one wished to explore a planetary system discreetly, a mothership could serve as a carrier, deploying tiny craft to orbit planets or even descend to surfaces. Mars, in particular, with its lack of protective magnetosphere and thin atmosphere, would be easier to reach than Earth. A probe could slip into orbit or even crash land without being noticed, its signals faint against the noise of natural background radiation. To this day, some enthusiasts argue that unexplained anomalies recorded by Martian orbiters, blips of radiation, flickers of light, could be the traces of such probes. Critics of the theory argue, of course, that extraordinary claims require extraordinary evidence. So far, no signal, no deliberate transmission, and no clear structural features have been detected from 3 Atlas. The faint data we have is far more easily explained by natural models, but the allure of the mothership theory persists, in part because it taps into a larger question. If an alien civilization were exploring the galaxy, how would we know? Would they announce themselves boldly, or would they pass quietly, masked as comets, leaving only faint anomalies for us to puzzle over? History offers perspective. Ancient cultures often saw comets as messengers of the gods, bearers of warnings or promises. The mothership theory is, in some ways, a modern echo of that view. Instead of divine messengers, we speak of alien technology. Instead of omens, we speak of reconnaissance. But the underlying theme is the same. When a strange visitor crosses our sky, we cannot help but wonder if it carries intent. The implications of the mothership theory are staggering. If 3 Atlas is artificial, it would mean that intelligent life not only exists elsewhere, but is capable of interstellar travel. That in itself would be a revolution, forcing us to rethink our place in the universe. But the details matter even more. What if its purpose is benign? An observation mission, gathering data on planets like Mars to add to a galactic archive? Or what if its mission is seeding, deliberately scattering organic material across planets to encourage the spread of life. This directed panspermia hypothesis has been proposed even for Earth's own origins. In that sense, Three-Eyed Atlas could be both mothership and gardener, carrying life between stars as part of a grand design. The darker interpretations, of course, cannot be ignored. Some speculate that a mothership could be scouting for resources or for potential targets. Mars, with its exposed surface and lack of strong defenses, would make an ideal site for testing. If probes were deployed there, they might already be monitoring the planet, waiting for the day when humans arrive in larger numbers. The unsettling possibility is that our colonization efforts could one day encounter not only native challenges, but also alien technology already embedded in the Martian soil. Skeptics emphasize that natural explanations should always come first. Tumbles, flickers, and accelerations are well within the range of ordinary cometary behavior, especially for objects forged in unknown star systems. But even skeptics admit that the data is thin, that anomalies remain unresolved. And in that gap of uncertainty, the mothership theory thrives. Human imagination is adept at filling voids. And the idea that an alien craft passed near Mars without us realizing resonates because it plays upon both fear and hope. Fear of the unknown, hope that we are not alone. For Mars colonists of the future, the mothership theory may carry more than symbolic weight. Living on a planet touched by an interstellar visitor, they might wonder whether they are walking among alien traces. Every unusual mineral vein, every unexplained signal in their instruments could raise suspicions. Did a probe land here centuries ago? Are we under observation even now? Such questions could shape their culture, their caution, and even their myths. Just as ancient peoples saw gods in comets, colonists may see aliens in anomalies, weaving stories of Three-Eyed Atlas into the identity of life on Mars. Whether true or not, the mothership theory matters because it forces us to confront the scale of possibility. The universe is vast, billions of years old, and filled with stars and planets. To assume that no one else has crossed the void may be the greater leap of faith. And so we watch objects like Three-Eyed Atlas with a mix of scientific rigor and mythic awe, knowing that even if it is natural, it still carries meaning. It reminds us that interstellar travelers pass through unseen for eons, perhaps bearing life, perhaps bearing technology, perhaps simply bearing mysteries we have not yet learned to solve. In the end, the alien mothership theory is not just about Three-Eyed Atlas. It is about us. It reflects our longing for contact, our fear of insignificance, and our hunger for stories larger than ourselves. Whether the comet is rock, ice, or ship, it has already fulfilled the role of messenger, not by carrying signals from another civilization, but by stirring within us the recognition that we are part of a galaxy alive with questions. And sometimes the question is more important than the answer. NASA and ESA's watch when Three-Eyed Atlas entered the solar system. Telescopes across the world scrambled to capture its faint glow. But the task of watching it closely, analyzing its chemistry, and predicting its trajectory fell largely to two organizations with the most experience in planetary observation: NASA and the European Space Agency, ESA. Their watch over Three-Eyed Atlas was not merely an academic exercise, it was a coordinated effort to safeguard future missions, protect planetary exploration from contamination, and seize a once-in-a-lifetime opportunity to study a true interstellar visitor. For NASA, the object presented a familiar yet thrilling challenge. The memory of Oumuamua still lingered, with its strange acceleration and its ongoing debate about whether it was natural or artificial. Borisov, the second interstellar visitor, had given astronomers a clearer picture of a comet-like body from another star system. Now, Three-Eyed Atlas was the third, and it seemed to combine elements of both. NASA's watch began with early detections by ground-based observatories, but soon their space-based assets joined in. The Hubble Space Telescope, though aging, still provided detailed imaging of the comet's faint coma. The infrared eyes of the James Webb Space Telescope, JWST, were especially valuable, allowing scientists to analyze the chemical signatures of its gases and dust. For NASA, Three-Eyed Atlas was not just another comet. It was a chance to compare interstellar chemistry with what we know from comets born in our own solar nursery. ESA-2 brought its expertise to the watch. The European Southern Observatory's Very Large Telescope in Chile trained its giant mirrors on the visitor, capturing spectra that hinted at unusual ratios of carbon dioxide and organics. Meanwhile, ESA's Mars orbiters were tasked with watching the planet during 3I Atlas's closest approach. If interstellar debris entered the Martian atmosphere, instruments might detect faint spikes in gases or unusual dust patterns. ESA scientists had long specialized in planetary atmospheres, and for them, Mars was a natural observatory for monitoring the cosmic encounter. The coordination between NASA and ESA was unprecedented in some ways. Both agencies had learned from past frustrations that interstellar objects pass quickly, too quickly for bureaucratic delays. By the time funding could be requested, designs made, and missions launched, the object would be gone. With 3I Atlas, there was no possibility of sending a spacecraft in time. But what could be done was a global, synchronized watch, pooling every available instrument to build a composite picture. NASA's Deep Space Network tracked its trajectory with precision radar, while ESA coordinated ground-based observatories in Europe to follow its light curve around the clock. For a brief few months, the two agencies functioned almost as one, sharing data in real time. One of the central goals of this watch was planetary protection. Both agencies understood that 3I Atlas was passing near Mars, the prime target of future human colonization. If debris from the comet seeded Mars with organic compounds, then every sample taken by Perseverance or returned to Earth would need to be interpreted carefully. Were the molecules Martian in origin or interstellar contaminants? NASA's Planetary Protection Office worked closely with ESA's Committee on Space Research to draft guidelines on how to categorize and label any unexpected chemistry discovered in Martian samples. Their watch over 3I Atlas was not only about astronomy, it was about ensuring that future discoveries on Mars would not be misunderstood. At the same time, both agencies saw opportunity. If interstellar dust truly fell on Mars, then the planet would become the first natural archive of alien star chemistry within reach of human exploration. The sample return mission planned by NASA and ESA suddenly gained new significance. It might not only deliver Martian rocks, it could also deliver fragments of 3I Atlas embedded within them. This possibility turned their watch into more than passive observation. It became preparation for what could be one of the greatest discoveries in science: physical samples of another star system's building blocks, collected without ever leaving our solar system. Their instruments recorded everything they could. JWST measured faint infrared signatures that hinted at exotic ices, perhaps frozen methane or carbon monoxide in unusual ratios. ESA's Rosetta Heritage scientists compared the spectra to the famous 67P comet, noting both similarities and sharp differences. NASA's Chandra X-ray Observatory even joined the effort, searching for emissions caused when solar wind interacted with the comet's gases. Every anomaly was cataloged. Was the faint acceleration due to hidden jets of carbon dioxide? Was the brightness variation the sign of a tumbling shard? Or did it conceal something stranger? The agencies made no definitive claims, but they did not dismiss anomalies either. Their role was to watch, to record, and to preserve evidence for future generations to analyze. Public fascination was impossible to ignore. Both NASA and ESA released images and updates, careful to temper excitement with caution. But the media could not resist headlines. Alien visitor near Mars. Comet from another star sprinkles dust on red planet. Scientists were interviewed on television, balancing speculation with sober analysis. NASA spokespeople reminded the public that natural explanations were the default, while ESA scientists spoke of the wonder of studying a true interstellar messenger. The agencies had learned from the firestorm around Oumuamua, and this time they were careful not to dismiss fringe ideas too harshly. Instead, they emphasized that science thrives on questions, and 3I Atlas was full of them. Behind the scenes, however, there were debates. Some scientists argued for greater transparency about anomalies, fearing that downplaying them would fuel conspiracy theories. Others urged caution, warning that exaggerating uncertainties could mislead the public. In both agencies, working groups formed to draft protocols for future interstellar visitors. The consensus was clear: this would not be the last. As telescope technology improves, we may detect dozens or even hundreds of interstellar objects in coming decades. NASA and ESA's watch over 3I Atlas was not just about one comet, it was about building the template for how humanity studies cosmic wanderers from beyond. Mars itself played an active role in the watch. ESA's trace gas orbiter monitored the atmosphere for spikes in methane or carbon dioxide that could indicate incoming dust. NASA's Mars Reconnaissance Orbiter watched the surface for any new impact sites, tiny craters that could betray falling fragments. Though no spectacular events were confirmed, the very act of monitoring Mars so closely turned it into a planetary observatory, a second set of eyes complementing Earth's. Some scientists propose that Mars may have already archived past interstellar encounters in its regolith, waiting for future missions to dig them up. 3 Atlas was simply the first time we knew to look. In cultural terms, NASA and ESA's watch echoed the role of ancient skywatchers. Thousands of years ago, priests and astronomers stood on ziggurats and temple roofs, tracking comets as omens. Today, the watchers are scientists with telescopes and satellites, but the impulse is the same: to pay attention when the heavens send something unfamiliar. The agencies framed their work in terms of data and planetary defense, but at its heart, their watch was an act of reverence for mystery. They knew they were observing something rare, fleeting, and perhaps profoundly meaningful. The legacy of NASA and ESA's watch may not be immediate answers, but enduring records. Every image, every spectrum, every trajectory calculation becomes part of the archive of human knowledge. Centuries from now, when new civilizations look back at the early era of space exploration, they will see that we noticed, that we watched, that we cared enough to measure a traveler from another star. Whether 3I Atlas proves to be nothing more than an ordinary interstellar comet or something stranger, the act of watching elevates it into history. In the end, NASA and ESA's watch is less about solving the mystery now than about ensuring we do not miss the clues. They remind us that we are only beginning to notice the galaxy's wanderers. Each one carries secrets from elsewhere, and each one offers a chance to test our science, our imagination, and our humility. 3I Atlas may vanish back into the dark, but the memory of how we watched it will remain, a testament to humanity's resolve to look outward, to seek meaning, and to never let a mystery pass unobserved. The final question: change forever? When astronomers first announced the discovery of 3 Atlas, the world reacted with curiosity but little urgency. After all, comets and asteroids are common in headlines, and to most this object seemed like just another icy body drifting past the sun. But as months passed and more details emerged, the hyperbolic orbit, the faint but unusual organics, the brush with Mars, a deeper question took shape. Could this interstellar visitor, humble and fleeting as it seemed, change Mars forever? And by extension, could it change the way humanity understands itself, life, and our place in the cosmos? The first layer of this question is physical. Could 3I Atlas physically alter Mars? The answer, strictly speaking, is yes, though in subtle ways. Even if the comet's main body never touched the red planet, its dust and debris may have fallen into the Martian atmosphere. Each grain of interstellar dust carries chemical history, isotopic ratios, and compounds forged under the light of another star. When such material embeds in Martian regolith, it alters the planet's chemistry. Future rovers, landers, and even human explorers could dig into soil and uncover molecules that did not originate in our solar system. That alone would be enough to say Mars had been changed. Not catastrophically, but meaningfully, its identity forever tied to a foreign star system. The second layer is biological. Could 3I Atlas seed Mars with the potential for life? Here the answer is far more speculative, but profoundly consequential. If the comet's dust contained amino acids, sugars, or even protobiological molecules, then it might enrich Mars' chemistry in ways that push it closer to habitability. Even if no life sparks now, the introduction of alien organics could create the foundation for it in the distant future. This is what makes the change forever question so potent. Once material from another star system lands on Mars, the planet ceases to be a purely solar system world. It becomes part of a galactic experiment, a meeting place for chemistries from different suns. Mars could, in time, serve as proof that life is not a local accident, but a universal tendency waiting to happen wherever the right ingredients meet. The third layer is cultural. Even before its close pass to Mars, 3I Atlas was interpreted by some as a messenger, a cosmic omen. Ancient peoples would have seen it as prophecy, a warning or blessing from the heavens. Today, though clothed in the language of science, the impulse is the same. People asked, is it just a rock? Is it a probe? Is it a mothership? Could it be deliberately scattering life's seeds? In these questions, we see that 3I Atlas has already changed us, if not Mars. It has reminded humanity of our hunger for meaning, our instinct to see purpose in the unpredictable. Whether we interpret it as natural or artificial, scientific or symbolic, it has forced us to confront our place in a universe that still surprises us. But perhaps the most profound dimension is psychological. Mars has long stood as the next frontier of human exploration. Colonization projects, though still decades away, are treated with increasing seriousness by space agencies and private companies. If 3I Atlas truly deposited foreign organics on Mars, then the first colonists will not step into a neutral environment. They will step onto a world already touched by another star. The psychological weight of that fact could be immense. Imagine standing on Martian soil and knowing that beneath your boots lie molecules older than humanity, born in a stellar nursery light years away. Colonists may feel less like conquerors and more like caretakers, living on a world that is already part of a galactic story. The change forever question also reaches into science itself. For centuries, humanity has sought to answer whether life exists elsewhere. Mars has always been central to that search. If 3I Atlas seeded Mars with organics, and if future missions detect unusual molecules, scientists will face a dilemma. Did life arise independently on Mars, making it proof of a second genesis? Or did life, or its building blocks, arrive courtesy of interstellar visitors like 3I Atlas? Either way, the discovery would be revolutionary. It would prove that life is not confined to Earth, but it would also blur the lines of origin. We may never know whether Martian life, if found, is Martian at all, or simply the galaxy writing its script across multiple planets. That uncertainty itself would be transformative, changing the way we ask questions about life in the universe. There is also the possibility that 3I Atlas is remembered not for what it did, but for what it symbolized. Just as Halley's Comet inspired awe in generations who never understood its physics, 3I Atlas may inspire myths and stories among colonists on Mars. In domes and outposts, children may grow up hearing tales of the star messenger that passed close to their world before humans arrived. For them, Mars will never be just a dead planet of rock and dust. It will be a world that once received a visitor from another star, a place touched by mystery. Myth and science will blend, as they always have, and in that blend lies the essence of being human. Of course, skeptics will argue that nothing has changed. They will say that 3I Atlas was simply a natural comet, one of countless that passed through our system unseen. Its dust will disperse, its body will vanish, and Mars will remain as barren as it was before. From this perspective, the change forever narrative is just human projection, another example of making too much of too little. Yet even this argument fails to erase the truth. The very act of asking the question has changed us. We now know that interstellar visitors are not rare. They are part of the fabric of our galaxy. The fact that one brushed past Mars is enough to alter how we think about planetary science, colonization, and life's origins. The cosmos is not a closed system, and neither are we. For NASA and ESA, the watch over 3I Atlas became a rehearsal for the future. More interstellar objects will come, and some may pass even closer to Earth or Mars. Each one will bring new mysteries, new data, and new debates. The legacy of 3I Atlas may be that it taught us to look carefully, to coordinate globally, to prepare ourselves for the unexpected. That lesson alone will shape the way humanity approaches interstellar science for generations to come. So, could it change Mars forever? The answer depends on how one defines change. If we mean geological transformation, the answer is probably no. Mars will not suddenly sprout forests or oceans because of a passing comet. If we mean biological transformation, the answer is maybe. Over long timescales, alien organics could mix with Martian water and soil, perhaps giving rise to new chemistry, perhaps even new life. If we mean cultural transformation, the answer is already yes. 3 Atlas has changed the way we talk about Mars, about comets, about life. It has become part of the story we tell ourselves about who we are and where we belong in the universe. In that sense, the final question is not only about Mars, it is about us. Will humanity allow itself to be changed by the knowledge that interstellar objects pass through, carrying alien chemistry and perhaps more? Will we see ourselves as isolated or as part of a galaxy alive with exchange and interaction? The comet will fade, its dust will settle, but the question will remain. And in that question lies the true change. The recognition that we are participants in a cosmic drama far larger than Earth, far larger than Mars, far larger than even our imagination has yet conceived. The final question, then, is not whether 3i Atlas could change Mars forever. It is whether it has already changed us, and whether we are ready for the next visitor, the next mystery, the next reminder that the universe is not silent, but filled with wanderers that brush against our worlds and whisper, "You are not alone."